Section 2.5, Proportion and Variation. So in this section, we're going to be studying this concept of proportionality of variation. So first, direct variation. And so, if we say that y varies directly as x, this means there exists some constant k. We'll call this constant k the constant of proportionality or the constant of variation. So there exists some constant k such that y equals kx. If we have inverse variation, then we say that y varies inversely as x. That means that there exists some constant k, the constant of proportionality, such that over x. Joint variation. Z varies jointly as x and y means there exists some constant proportionality k such that z is equal to k times xy. Let's do some examples. On page 261, let's do problem number 18. Find the constant of proportionality. If z is directly proportional to t, so that means that z is equal to some constant k times t. If t equals 7, then z equals 21. T equals 7, then z is 21. Let me divide both sides of my equation in order to solve for this constant proportionality. And so k, my constant of proportionality, is just equal to 3. And so the constant of proportionality is 3. And that is your answer. Let me do problem number 24. Solve each problem. So problem 24. W is directly proportional to z. If W is equal to -6 when z is equal to 2, find W when z is equal to -3. And so I have that W is directly proportional to z. So there exists some constant of proportionality k such that W is equal to kz. And so W is equal to -6 when z is equal to 2. Divide both sides of your equation by 2, and so k is equal to -6. Therefore, W is equal to k -6z. I want to find W when z is -3. Well, negative times negative is positive. Ooh. 6 divided by 2 is 3. Okay. That was an error. So negative times negative is positive. Therefore, W is equal to +9. Let me do problem number 37. Gas laws. The volume of a gas varies directly as the temperature. So let me write that down. Let me get some space to write that down. So the volume varies directly as the temperature. So V is equal to K times T, the temperature. And inversely as with the pressure. Oops. And inversely with the pressure. Okay. So V varies directly as the temperature, but inversely as the pressure. Okay. And so I have, when the temperature is 330 degrees, the pressure is 40 pounds. So when the temperature is 330, the pressure is 40. I can divide each of these by 10. And the volume is 20. And so 20 is equal to 33K over 4. Let me multiply both sides of my equation here by 4. And so I have here that 33K is equal to 80. Divide both sides of my equation by 33. So K is equal to 80 over 33. Therefore, my volume V is equal to K, 80 over 33, and multiply by T over P. Okay, so now let's try to figure out, I guess I'll need another page here. So, try to move. Okay, here it is. So it says, find the volume when the pressure increases 10 pounds, so from 40 to 50, and the temperature decreases to 300 degrees Celsius. Okay, so let's do that. So let's figure out what the volume is. And so I have V is equal to 80. So the temperature has increased or decreased to 300 over 33, and the pressure has increased by 10 from temperature decreases and the pressure increases 10 from 40 to 50. Okay. So let's simplify this. 300 divided by 50 is 6. I can divide both 6 and 33 by 3. And so 60 is 2 times 80 is 160. 33 divided by 2 is 11. And so your volume is 160 over 11 cubic feet, or let's actually divide this out. So it's 14.5 cubic feet. And so that is the volume. Let me do problem 44. 4-ish, okay. Let's move this up a little bit. So I have some room here. Yeah, that looks good. And then let's move this guy back up. Okay, so let's do this problem. I guess that's the last one to do. Problem number 44. It's on illumination. So, intensity of illumination from a light source varies inversely as the square varies as the square of the distance varies inversely as the square distance from the light source. If the intensity of the light source is 100 lumens and the distance is 15 feet. So we have 100 lumens and a distance here of 15 feet. Find the intensity. So first let's figure out what this is. And so I have 100 is equal to K over 225. Let me multiply both sides of my equation by 225. So that says that K is equal to 22,500. And so I have that the intensity I is equal to 22,500 over the distance squared. So I want to find the intensity when the distance is 25 feet. So I have 225 over 25 squared. And so the intensity is 22,500 over 625. And so let's divide that. So my intensity is 36 lumens. And that is my answer. And so